Hello everybody, today we're going to look at the half angle, double angle, and power reduction formulas for sine and cosine. So, if I wanted to find the sine of 2 theta, well, I can rewrite this as sine of theta plus theta. In this form, I can now use the angle addition formula. So, remember, sine was sine cos cosine, so this is going to be sine theta cos theta plus cos theta sine theta. Now, since both of these angles are the same thing, this is just 2 sine theta cosine theta. So that's sine 2 theta. Now, for cosine 2 theta, I can do exactly what I did for sine and rewrite this as cosine of theta plus theta. Now remember, cosine was cosine sine, so this is going to be cosine theta minus sine theta sine theta. This is cosine squared theta minus sine squared theta. This is the first form of double angle for cosine. Now think back to the Pythag identity. We know that sine squared plus cosine squared is equal to 1. So solving for cosine squared, I can get that cosine squared theta is 1 minus sine squared theta. I can take this form, plug it into my equation. I get that this is simply 1 minus sine squared theta, that was cosine squared theta, minus sine squared theta. And we end up with 1 minus sine squared minus sine squared. This is going to be 1 minus 2 sine squared theta. Now over here, again, I can solve for sine squared theta. And this is 1 minus cosine squared theta. Subtract cosine squared theta from both sides. And I can take this result and plug it back into my first equation to get cosine squared theta minus this entire thing, 1 minus cosine squared theta. Cosine squared minus negative cosine squared, this is 2 cosine squared theta minus 1. And here are our double angle formulas. For cosine, these 3 forms, you must know all of them. So get familiar with all 3 of these forms. Now, for this equation right here, this was the second form of double angle for cosine. Now, if I wanted to solve for cosine squared, I can move the minus 1 to the other side. Cosine of 2 theta plus 1 is 2 cosine squared theta. Now I can divide both sides by 2. So this side, I will end up with cosine squared theta. This side will be all over 2. This is cosine of 2 theta plus 1 all over 2. And this is my power reducing formula. As you can see, we went from a second power to the first power. We've reduced the power. Now, taking our power reduction formula, I can let theta equal half of alpha. And what I end up with is that cosine squared of 1/2 alpha will be 1 plus cosine of alpha over 2. I can solve for cosine of 1/2 alpha by taking the square root. So cosine of 1/2 alpha is plus or minus the square root of 1 plus cosine alpha over 2. Now, we determine if this is positive or negative depending on what this angle is. If this angle is in the first and fourth quadrant, this will be a positive square root. If this angle is in the second and third quadrant, this will be a negative answer. We can get the half angle and power reduction formula for sine squared through a similar method. Now, this is form 3 of double angle for cosine, and this gives me only sine squared theta. I can solve for sine squared theta by subtracting 1, so cosine of 2 theta minus 1 is negative 2 sine squared theta, and I can divide both sides by -2. So this will become sine squared theta is equal to -1 and a negative. This is going to be 1 minus cos 2 theta all over 2. So this was the power reduction formula for sine. As you can see, we go from sine squared to cosine. The power has been reduced. Now note that we don't have a nice formula to go from sine squared to just sine. If I wanted the half angle identity for this, I can set theta equal 1/2 alpha. Plugging all this in, sine squared of 1/2 alpha will be 1 minus cosine of alpha over 2. This will be 2 times 1/2 alpha, which is simply alpha. Right, now I can solve for sine of 1/2 alpha by taking the square root of both sides. This will be plus or minus the square root of 1 minus cosine alpha over 2. And this plus or minus is determined on where this angle is. If this angle is in the first or second quadrant, sine will give a positive answer. If this angle is in the third and fourth quadrant, sine must give a negative answer. And here is a summary of all the formulas we have covered in this video. Sine 2 theta will be 2 sine cos. Cosine 2 theta has 3 forms: cos squared minus sine squared, 2 cos squared minus 1, 1 minus 2 sine squared. Get familiar with all 3 of these forms. Sine squared is 1 minus cos 2 theta over 2. Cosine squared is the same thing, except 1 plus cos 2 theta over 2. Both of these equations come from the second form of double angle. Sine of 1/2 alpha, we do a change of variable from theta to alpha, and we get plus or minus the square root. Cosine of 1/2 alpha, similar change of variables, plus or minus the square root. The positive or the negative version is dependent on whether if sine is positive or negative in this angle's quadrant.